Alright, so again, evaluating a piecewise defined function. So they're giving you this function in different notations here. So one of the things you want to do is you want to see here that if x is less than or equal to a -2, then you're going to plug in your x value into this part of the function. So when x is less than or equal to a -2, you would take that value, times it by a -1/4, and subtract 2, and that would give you your y value, or your output. So remember that this g of x notation just represents the output. It's like saying y, but when you see it written as g of x, it's telling you that it's a function. Okay, so it's giving you a little bit more information. And functions have different properties than other equations, so knowing that it's a function can be helpful. So, okay, so here is another piece to your function. That's why they call it piecewise defined function. Now, when x is greater than -2 or less than 2, you're going to plug it into this part of your function. So you would take your x value, square it, and -3, and that would give you your y value back. Okay, and over here, when x is greater than or equal to 2, it's telling you, if your value obviously is greater than or equal to 2, so like 3, 4, 2, any of those values, you're going to plug those into your function by multiplying them by 1/2 and adding 1, and that gives you your y value back. Okay, so down here, this is what it's asking you to find. It's asking you to find g of -2. And so it's basically asking you, when you see that, it's telling you to find the y value when x is a -2. So you've got to come up here, and where does this fall into? Which piece is this? X is equal to a -2, so here's a -2, and there's an equal to part here. So it's going to fall into this group right here. So what you're going to do is you're going to replace x here with a -2 and simplify this. So -1/4 times a -2 minus 2. Okay, so -1/4 times -2, remember we can think of that as -2/1. So we can simplify this. These can both be divided by a 2, so that gives me 1 and a 2 here. And so a negative times a negative is a positive. 1 times 1 is 1. And 2 times 1 is 2. And then we're going to be subtracting 2 from that. Now if you're going to subtract 2, you could change this to, a lot of us can do 1/2 minus 2 fine, but you can always get a common denominator here. Think of this as 2/1. So if I want the denominator to be 2, I'd multiply this by 2/2. 1/2 minus 4/2 is a -3/2. So part of my solution is g of -2 equals to a -3/2, or you could say a -1.5. That's the same thing. Okay, so that's one of my solutions here. So it's telling me when I input a -2, I get a -3/2 back. This is my x, and this is my y. Okay, so let's do this for the next value here, g of 1. So we need to find out where does that fall in. That falls into our middle region here. 1 is in between 2 and -2. So I'm going to plug this into this part of the function here. So I'm going to take my 1, square it, and subtract 3. 1 squared minus 3. So I do my order of operations here. 1 squared is 1. And so 1 minus 3 is a -2. So there's another solution. When I input a 1 into my function, I get a negative 2 back. So we write that as g of 1 equals negative 2. Okay, so we have one more function to evaluate here. When g is, g of 4 means what is my output when x is 4. So, okay, we come up here and we see x is 4 is going to fall into this region here. 4 is greater than or equal to 2. So I'm going to plug it into this value here. 1/2 times 4 plus 1. 1/2 times 4. I'm going to write that as 4 over 1 plus 1. So we can simplify these. We can divide the 2 and the 4 both by 2. And that gives me 1 and a 2. And then we multiply across. 1 times 2 is 2. Whoops. Okay, that'll be a big equal sign there. So this gives us 2 over 1, which is just a 2. 2 plus 1 is 3. And you get your final solution, g of 4 equals 3. So when you input a 4 into your function, you get a 3 back.